Naval Warfare Tactics. We need to establish knowledge of how ships operate tactically before we can proceed to the operational and strategic levels. Here you can see a depiction of the use of Greek fire by the Byzantines against an enemy fleet. Victory or defeat in naval warfare has always depended on the correct application of the principles of war. The correct application of the principles of war in turn depends on understanding the available naval technology. The world has evolved essentially from muscle-powered oared vessels such as triremes. You can see on the left the bireme, typical of the Mediterranean, from the classical period right up until the early modern period, at such battles as Lepanto, and the use of oared vessels in the difficult icy environment of the Baltic. On the right you can see the Korean turtle ship, which was decisive in the Korean and Ming Dynasty attempt to block the Japanese fleets deploying troops during Hideyoshi's invasion of Korea in the 16th century. Here's a close-up of the Korean turtle ship at a museum in Seoul. The next evolution were sailing vessels capable of transoceanic travel and armed with cannon. These types of ships, as they evolved, were able to circumnavigate the entire Earth. First, in a fleet led by Magellan, although he himself did not make it around the entire Earth, and then led by Drake. These fleets, by the 18th century, had more cannon than all the cannon of their respective armies. You can see here the HMS Victory, which was the lead ship at the Battle of Trafalgar. Here's HMS Victory at the Battle of Trafalgar. You can see Lord Nelson, about the middle right, having been fatally wounded by a French sniper at the Battle of Trafalgar. The next step in the evolution was to the rifle-gunned, steam-powered metal ship. This is the German Blücher in 1910, a battleship of the German fleet. To today, where we have missile and aircraft armed with nuclear weapons, and a navy that basically uses electronics for surveillance, operating off of aircraft carriers and submarines. This is a picture of the Russian Admiral Gorshkov aircraft carrier during sea trials in the 1980s. The first principle of the selection of the aim is dependent on political authorities, as always. So the case we're going to use today, the background of a naval battle, is the conflict between Argentina and England over the Falkland Islands, also known as Las Malvinas. On April 2nd, 1982, Argentinian forces, under the government of a junta consisting principally of Generals Galtieri, Admirals Anaya, and General Dozo, invaded the Falklands Islands, or Malvinas. You can see on the left the strategic map and the great distance between England and the Falkland Islands, as well as the associated island of South Georgia and the South Sandwich Islands in the South Atlantic. The British staged out of Ascension Island. You can see on the right the two halves of the Falklands, the West Falklands and the East Falklands. Most of the conflict occurred in the northeast of the East Falklands, and that's where you have most of the cities located, including Stanley, the largest town and the capital, which is at the extreme east of the northeast section of the Falklands. It's It's there that most of the land operations occurred and where the Navy was supporting the land operations. You can see pictures of, from left to right, Galtieri, Anaya, and Brigadier Dozo in Buenos Aires. You can also see on the bottom left Argentinian Marines taking the British Royal Marines prisoner after a short firefight. There's a good film that is quite realistic, depicting this initial invasion by the Argentines. You can see on the top left Argentine soldiers, a British soldier with a Bren gun in the bottom left, and you can see the map of the Falkland Islands. Here you can see a rough highlight of the main operations that occurred when the British returned and attempted their reconquest of the Falkland Islands. The British fleet consisted of the Hermes and the Invincible, 2 light aircraft carriers, along with their escorts, and they deployed in mid-April after traveling the 12,000 kilometers from the UK to the South Atlantic. On April 25th to 26, 1982, South Georgia, the associated island to the southeast, was recaptured by the British. On May 2nd, 1982, the British submarine HMS Conqueror sank the Argentine cruiser General Belgrano, resulting in 368 killed sailors. The next day, May 3rd, 1982, the British sank an Argentinian patrol boat. A day later, on May 4th, 1982, the British ship HMS Sheffield was struck by an Exocet missile launched from an Argentinian aircraft, the Super Étendard, that had deployed out of Argentina. On May 7th, 1982, the British extended the exclusion zone to Argentina's 12-mile limit. In other words, the British declared they would sink all Argentine vessels that were outside of the territorial waters of Argentina, wherever they were in the ocean. This map also depicts the Vulcan bomber and Sea Harrier strikes on the airfields. The Sea Harriers were aircraft that were operating off the aircraft carriers that were moving off the coast, and the Vulcan bombers were staging out of England. And it says here, Ascension Island. This is the landing by the British Marines from the flotilla on the northeast section of the Falkland Islands and the advance to Darwin, Goose Green, and Stanley, where the final fighting occurred. On May 21st, 1982, the British land at San Carlos Bay, which you can see in the top left of the map, in the blue shaded area. It was basically a cove which provided protection to ships against long-range anti-ship missiles because of the hills around the cove. But it did make the ships a good target for Argentinian aircraft that were dropping gravity bombs. On May 21st, 25th, the British Amphibious Force loses 4 ships, and Argentina loses 36 aircraft in the fight in San Carlos Bay. The British then marched across the island, conducting various operations at Goose Green and a series of fights around hills that were to the west of Stanley. And then Argentina surrenders on June 14th, 1982. Now, modern naval combat, and this really means since the early 1960s, is based on the long-range missile, very often over the horizon. In other words, missiles fired at targets that are invisible because of the curvature of the Earth. The first anti-ship missile was used by the Germans in 1943 to sink the Italian flagship Roma. It was a wire and radio-guided air-dropped missile called the Fritz X. And if you look carefully at the picture underneath the wing to the left, you'll see the Fritz X hanging off of the wing of this aircraft. This is the Fritz X. Currently, the most popular anti-ship missile is the American Harpoon. which is essentially a high-accuracy cruise missile with a range of 120 kilometers. Some Russian anti-ship missiles have over 500 kilometers in range. Here you can see two of the vessels that were operating during the Falklands War, the HMS Conqueror submarine and the HMS Penelope. This is a scan of a chart from James F. Dunnigan's How to Make War, an earlier edition showing different anti-ship missiles. And you can see in the column on the left the ranges that go anywhere from 40 kilometers right up to 500 kilometers. It also compares the ranges of torpedoes, guns, and ASROC. ASROC are torpedoes that are deployed via a rocket. Here you can see an anti-ship missile coming in to hit a ship. Modern ships are typically unarmored, and the warheads on rockets have less explosive power and less penetrating power than the very large shells of the 15, 16-inch guns of the First and Second World Wars. This is a picture of the USS Stark, which is an American ship that was hit in error with an Exocet missile by the Iraqi Air Force. This is the distant view after the ship had a breach put in its hull, and it started taking on water, causing it to list. It was ultimately saved. 37 Americans were injured or killed. This is a close-up of the damage done by the Iraqi Exocet missile. To stop Exocet missiles, and like anti-ship missiles, there are a number of countermeasures. Some are passive. In other words, they put out aluminum foil, or they have electronic decoys to try to fool the rocket. There are also close-in weapon systems, which fire a wall of depleted uranium or tungsten core bullets to try to capture and damage the missile before it hits the ship. This is a modern version of that. It's a laser gun which attempts to burn and damage the missile as it comes in. Its advantage is that the number of shots is limited by the amount of electrical naval power. This is a railgun which uses electromagnetic propulsion. The bullet is a piece of metal, and the energy is supplied electrically, and it's still under development. You can see a CWIS, or a close-in weapon system, on the top right. In principle, naval warfare is a harsher variant of the principles of war, with a particular emphasis on the concentration of force. While command and control is easier, despite the ever-presence of friction, there is a smaller margin of error for victory. The key to victory in naval operations is the successful application of the offense. Naval warfare is essentially about attrition, the destruction of the enemy fleet. There is no advantage in being in the defense at sea, because there are no defensively favorable geographic features on the ocean surface. Thus, maneuver and the initiative that makes it possible, which are the third and fourth principle of war, are crucial. Surprise, the result of initiative, creates a much greater results in naval warfare than it does in land warfare. This is the application of Boyd's decision-making cycle, which you've seen before, applied to naval warfare. And it's about using the sensory information at long range, processing it, and then acting in order to defeat the enemy fleet. There are three modern platforms in naval warfare. All weapon systems in naval warfare have nuclear equivalents. First, there's air power. These consist of fast-moving aircraft, some of which are designed to fight ships specifically, or to fight other aircraft, or to hit land targets if operating off an aircraft carrier. There are also long-range maritime reconnaissance aircraft, which are designed to fight and find submarines, as well as other ships, and to monitor civilian ships. And there are helicopters designed to fight submarines and ships. All of these variants will likely have drone equivalents. The weapons they operate are air-to-ship and air-to-air missiles, depth charges, which are underwater explosives used to destroy submarines, torpedoes, and mines. Here you can see the deck of a British aircraft carrier. These are some of the aircraft of a 1980s era U.S. aircraft carrier. Starting on the far right, you have an aircraft with a radar on top. That's the E-2C, the most valuable aircraft on an aircraft carrier, because this radar allows the aircraft carrier to see at a great distance without disclosing the exact location of the aircraft carrier. So this aircraft would take off. It would not turn on its radar, because that would indicate where the aircraft carrier was. It would fly to a very high altitude, because the higher you fly, the greater the coverage of the radar. And it would fly at some distance, probably 100 kilometers or even several hundred kilometers from the aircraft carrier. Because it's a turboprop aircraft, it flies quite slowly, which makes it vulnerable, but it also allows it to loiter. In other words, fly slowly for a very long time. So it's able to stay in the air. And there are at least 4 of these on each aircraft carrier. Immediately to the left of the aircraft are 2 F-18s. These are less expensive, robust platforms, and they can operate as fighters. They can operate Harpoon missiles to fire against ships, and they can drop ordnance against ground targets. So they're very versatile aircraft. Immediately to their left is an S-12, which is an aircraft that chases submarines. It's dedicated to hunting down submarines. It uses sonobuoys, which are dropped microphones in the water that float, and if it detects a submarine, it can drop either a depth charge or a torpedo. In the bottom of the screen is an F-14. There's also an F-14 on the top left of the picture. These were the premier fighters in the world. There were 2 pilots. One was one pilot that flew the airplane, and the second individual who simply operated the radar. This aircraft had the largest radar at the time in its nose, and it was a very fast aircraft with a very heavy payload. It had a sole mission. Its mission was to defeat the large array of supersonic, very long-range Soviet anti-ship missiles. Some, like the Kangaroo, which were the size of a bus, and could fly 3, 4, or 5 times the speed of sound. And these high-altitude cruise missiles would fly high, identify the aircraft carrier, and then plunge down. These F-14 aircraft carried the Phoenix missile, which is a 200-kilometer range missile designed to shoot down the cruise missiles or to shoot down the Soviet bombers, typically the Tupolev-22M or the Tupolev-26 backfire bombers that would launch these cruise missiles at a great distance. So the F-14 also had a great distance, and the Phoenix missile it carried was also supersonic, flying up to 3, 4, or 5 times the speed of sound. On the extreme left, you can see at the bottom of the 2 is an A-6 Intruder. This is a bomber aircraft. It was very good at flying low. It could carry anti-ship Harpoon missiles, or it could carry ordnance against ground targets. The aircraft immediately above it is an A-6, EA-6 equivalent, which is an electronic warfare aircraft, and it was designed to suppress the radars of enemy ships and radars located along coasts. And so this group of different types of aircraft typically numbered about 90, including helicopters that would be used in the anti-submarine warfare role, as well as some utility aircraft. And this is what gave the aircraft carrier its power. The aircraft carrier itself didn't have, at least the American aircraft carrier, didn't have any weapons of its own. This is the British HMS Hermes aircraft carrier, which is light, and you can see it's got Harrier aircraft, which are VTOL aircraft. In other words, they're short takeoff and landing, so they would jump off of the ramp, which you can see on the bottom right, but they could also take off vertically, although that wouldn't be recommended because it uses a very large part of its fuel supply. These are aircraft carriers of different countries. You've got the Gerald Ford on the top left, the Chinese Liaoning, and the Chinese are now onto their third carrier. The Admiral Kuznetsov, which has had severe problems, mechanically speaking. You've got the British HMS Queen Elizabeth, of which there's 2 types. You've got the Indian carrier, the French carrier, the Brazilian carrier. The US has a large number of commando carriers, which are essentially not aircraft carriers. They use the deck for aircraft, but primarily to use helicopters to land Marines on coasts. You've got an Italian carrier, the Spanish carrier, the Japanese carrier, of which there's more than one different class, and then the Thai carrier, which is being decommissioned. This is a map of the range that aircraft had from coasts during the Battle of the Atlantic in the Second World War, where the Allies, principally the Americans and the Brits, but also their allies like Brazil and Canada, were escorting convoys and attacking German submarines that were trying to stop the convoys from resupplying Allied forces in Europe, principally in England. And it was a war in very difficult circumstances using advanced technology like Acoustics, sonar, and aircraft patrolling and dropping anti-submarine ordnance in the form of depth charges using radars to detect periscopes. And the submarines themselves were using various technologies to maximize the amount of time they would stay underwater, including batteries. The second platform in naval warfare are ships, including surface combatants, some specializing in ground support, such as battleships, in air defense, such as Aegis computer and radar cruisers, in escort, in other words, they'd be helping collections of civilian ships in convoys be protected from air and submarine attack, and anti-submarine warfare, also known as ASW, and in anti-ship missions. And it includes aircraft carriers, support vessels, which often outnumber the fleet itself to keep the fleet supplied with fuel and munitions and food, transports to carry Marines to conduct landings on islands and coasts. Weapons include anti-ship missiles, surface-to-air missiles, anti-submarine torpedoes and depth charges, aircraft and helicopters, bombs, and ship guns. Here you can see the British ship, HMS Fearless, which is an amphibious assault ship. It carries in the back various amphibious vessels to conduct coastal landings. This ship was one of the ships used to land British Marines during the attack on the Falkland Islands. The Americans generally have less emphasis on anti-ship missiles because many American ships are escorts for the 10 U.S. aircraft carriers, and that's where the U.S. focuses the bulk of its firepower. However, if measured in terms of vertical launch systems, a vertical launch system is a vertical tube in the hull of a ship, and it's the primary way that the U.S. launches ordnance, whether it's anti-ship, anti-air, anti-submarine. You have these vertical columns and tubes in the deck of a ship, and you simply change in or change out whatever kind of ordnance you want in those tubes. The U.S. Navy has an order of magnitude more tubes than its main opponents, including the Chinese. So even though the Chinese have more vessels, the Americans have more vertical launch systems in the ships that operate at sea. But ships only carry 4, 8, and maybe 16 anti-ship missiles, and then they would have to be resupplied. And many of those ships could only be resupplied in port and not at sea, or under anchorages where there are logistical supply ships. But the Americans generally focus on getting their power from aircraft carriers, whereas the rest of the navies in the world focus on their surface ships that are not aircraft carriers, carrying more than the average number of anti-ship missiles. This is the HMS Type 42 destroyer Sheffield. It's this ship that was damaged and then sunk by the Argentinian Exocet during the Falklands War. The third platform is the submarine, and these include hunter-killer submarines that can destroy both submarines and surface ships, and ballistic missile submarines used to carry the strategic nuclear forces of countries. The ballistic missile submarines generally avoid combat, and only the Americans, Russians, Chinese, Indians, English, and French have ballistic missile submarines. And these submarines have vertical tubes in them, and they generally stay far out to sea and very deep and avoid contact. The weapons of these ships, of these submarines, include anti-ship and anti-submarine torpedoes, cruise missiles, and mines. Torpedoes are the highest priority threats for naval ships because they're the most likely to sink a ship with a single hit. They're the hardest to detect, and they're impossible currently to destroy. Once they're in the water moving towards a ship, all a ship can do is avoid them. As compared with an anti-ship missile, for example, launched from an aircraft at great distance, those missiles come in very quickly, but there are systems to shoot them down, and the ship has decoys to avoid a near hit from an anti-ship missile. And the warheads on torpedoes generally are much larger than the warheads on anti-ship missiles. Here you can see the Argentinian submarine Santa Fe, which was hit by a missile launched by a helicopter in South Georgia Island. And this caused it not to be able to submerge, otherwise it would fill up with water, and it therefore surrendered to the British Navy. On the right you can see the Russian Shkval supercavitating rocket torpedo. This is a short-range rocket, not a torpedo. It only flies for about 15 kilometers, requiring the submarine to get very close to its target. But underwater, it releases a gas envelope from its nose, which reduces the friction in the water significantly, allowing it to move at 300 kilometers an hour under the water. This is a map of an attack by a Pakistani submarine off the Gujarati coast in India that sank an Indian ship in 1971. So it shows the damage to the kukri, where the kukri was hit, as it was being pursued by the submarine. So these are different types of anti-submarine warfare systems, looking at the numbers on the graphic on the right. The first is a rocket-launched torpedo. These can be launched by ships or submarines once a detection is made, or suspected detection, because the torpedo will go through a search pattern. You can also see that on serial number 8. There's a towed sonar array, and a towed sonar array is a wire with a microphone at the end that is let out both by ships and submarines. They generally don't work if either the ship or the submarine is going too quickly because of the disruption of the sound waves caused by the propeller. Number 2 are anti-submarine warfare helicopters. These typically operate off of ships on the back deck of a ship where there's a garage for the helicopter. Number 3 are underwater acoustics and sea mines. During the Cold War, the Americans had something called the SOSUS system deployed in the Atlantic to track some of the 300 submarines operated by the Soviet Union. And it was feared that the Soviet Union would move these from the USSR across the GI-UK gap, which is the gap of water between the Arctic Ocean and the North Atlantic, between Greenland, Iceland, and UK, United Kingdom. And so there were underwater microphones that would listen to the submarines passing through. There's a bit of an issue now because the US and the People's Liberation Army Navy of China use drones to track the microphones, and it's possible that the countries are interfering with each other's microphones located on the seabed, particularly since China claims ownership of the South China Sea. Number 4 is satellite surveillance. These are satellites that look for things like periscopes or submarines on the surface. Number 5 are hunter-killer submarines, and number 6 are maritime patrol aircraft. The maritime patrol aircraft you see on the top left of the graphic has a long tail at the back, and that's called a magnetic anomaly detector, and it essentially detects metal immediately below the aircraft for several hundred meters. So it's very useful for detecting very close, very deep submarines. And once a submarine is detected, this aircraft can drop depth charges or torpedoes to begin a search pattern looking for the submarine. You can see in the photograph on the left a Sea King helicopter of the US Navy dropping a sonobuoy, which is a microphone. Key aspects of naval warfare are scouting and detecting with sensors. This is vital, as is the role of jamming sensors and engaging in counter scouting techniques. In other words, avoid being seen. In naval warfare, surprise is devastating, so it's very important to hit first and therefore not to be seen. This is especially true when thinking of nuclear weapons at sea. An important role is also played by passive sensors. These are microphones in the water that listen to the movement of ships and submarines through the water, as well as listening to the background noise of the ocean, the whales, earthquakes, and waves, and distinguishing between the two. But we're getting to a point where submarines are so quiet, they're quieter than the background noise of the ocean. And there's the perpetual problem of the amount of activity on the ocean of civilian ships is increasing every single year, and the ocean is becoming a very noisy place. Another issue is avoiding radars from enemy ships, coastal radars, and the radars of high-flying enemy aircraft that can detect. And there's just a general principle, which is that active sensors allow you to see targets that are very close with great resolution. But active sensors, because they emit electromagnetic energy, whether it's the sound of a sonar, the ping, as the active sonar sends out a loud noise to capture the bounce back waves, or whether it's transmitting radar, those indicate your location very clearly. Consequently, most ships do not actually operate their radars in wartime. They do in peacetime for navigation purposes. To operate your radar or your active sonar gives your position away. And although active radar and active sonar allows you to see targets nearby with great clarity, by turning them on, you're actually exposing your position to 10 times the distance of your active system to passive systems. So there are systems called ESM, electronic security measures. These detect active radars in the distance. So even though every ship is equipped with a radar, typically ships will not operate with a radar. You will have ships turning radars on intermittently and then moving to a new location. It's a very complex process. It's all done with a view to not permitting the enemy to detect the location of your flotilla, because that would give them an enormous advantage. So you want to trick your opponent to operate first. So ships will very often communicate using lights if they're nearby, or they'll use laser point-to-point communications to coordinate information between ships. Now there are some exceptions. Some very powerful ships in terms of air defense and in terms of radar, like the U.S. Aegis cruisers, the Ticonderoga class, their radars are very powerful and they reach out very far, and they're very good at coordinating the air defense systems of other ships in a flotilla by communicating to them directly through lasers. And so those radars typically operate because even though these ships are detected, sometimes they do indicate the location of an entire flotilla, their reach is so far out with the radar and their anti-air missile systems that knowing where they are doesn't give necessarily a huge surprise advantage if the radar is operating. because that radar can be used to shoot down incoming missiles with the systems that are carried by the Ticonderoga class. Usually these ships are grouped together with other ships with a large concentration of defense systems in a layered level, like an onion. So you've got ships with close air defense, ships with medium air defense, and then you've got your Ticonderoga class that have an outer defense perimeter. So enemy incoming missiles or aircraft have to survive these multiple layers of air defense. Now at long range, sensor resolution is going to be quite low. You're not entirely clear what it is that you're detecting, whether it's an aircraft or a missile. And aircraft flying very low and missiles flying very low near the surface of an ocean, especially if the ocean is rough, may get quite close to a flotilla before they're detected. With sensors, you could get a rough idea of the bearing, in other words, the direction of the enemy contact, but you have to spend time to get better resolution or get closer in order to get enough resolution to be able to fire a missile, like a cruise missile, that can then begin a search pattern. So the cruise missiles can find a target on their own, but they need to have a general idea of the direction of the contact. Otherwise, they're simply going to be patrolling through empty ocean. So the basic physics of it is that you're doing scouting patrols with aircraft, and this takes a long time. Doubling the search range of an aircraft quadruples the area to be patrolled. So if you think of a square and the formula to measure the area, if you had a square with one of the sides equaling 1 square kilometer, or a square nautical mile if we're talking in terms of naval measurements, then the area of that square is 1 nautical mile. If you have a square with one side that is 2 nautical miles, then the area formula is one side times the other side, and it's 2 by 2 is equal to 4. If you had a square with a 3 nautical mile side, it would be 3 times 3 for the formula of the area. That's 9 square nautical miles. And so you can see an exponential increase in the amount of surface area and area to be covered. So aircraft that reach out in a particular direction that double the distance have a huge increase in the surface area required to be covered. So this is an important element of the physics of how to calculate area that translates into the amount of time required by patrol aircraft to detect a target. Here you can see visually a clear idea of the patrol area of an aircraft. So it's going to be a segment of a circle, and you can see visually how increasing the range significantly increases the area. Now, a critical aspect of ship combat is that a single ship has a high probability of sinking targets more valued than itself. That's because you have a ship and it's got 4 or 8 anti-ship missiles. So in the Lanchester equation, you actually have the small r or the small b, which indicate the number of targets that can be hit. In the Lanchester equation we did for land combat, that value is 0.01. In essence, 100 soldiers will likely hit 1 soldier over a unit of time as they're firing back and forth. But in naval warfare, that r could be a whole number, like 3. In other words, one ship can sink 3 other ships. Now, one big attenuation of this value is the fact that when you have a long-range system, you are also vulnerable to the enemy's long-range system. And so to minimize your vulnerability, you're going to move into the area where you can be a target, fire off your ordnance, and then get out. This means that you're almost always going to be firing at extremely long range. This gives the enemy to move their ship to another location. The long flight time of your missile means the enemy has, if they have their radars on and they detect it, a long time and many opportunities to shoot down that missile. So the longer range that a contact and an engagement is made, the weaker the value of your attack systems. Here you can see a U.S. standard surface-to-air missile launch. This missile has evolved over time, and the SAM-3, the Standard Missile 3, can actually be used to shoot down low-orbiting enemy satellites in space. So each individual ship can sink 3 other of its own. So the method, therefore, must be concentration of fires with the same theoretical effects as described by Lanchester. But you're not thinking in terms of ships, you're thinking in terms of launching platforms. So there are different tactical methods of attack. There's the sequential attack, which is an alternative, in which you have groups of ships after groups of ships firing at the same target. The advantage of a sequential attack, even though it's not following the principle of the concentration of force, where you overwhelm a defense, is that when you fire your missiles, it'll hit a number of targets, and then you'll have time to do battle damage assessment. In other words, fly an aircraft out to see what you hit, or use your radars to see which ships are sinking in order to determine what effects you had. One of the consequences, unfortunately, of the current missile tech is that they're not too intelligent. So if you have a ship that's hit by a rocket and is then on fire, other ships will then take cover behind the shadow of that ship. And new missiles coming in will all concentrate on that very obvious target. So you don't want to waste missiles on ships that are already sinking. So the sequential attack permits you to engage in a volley, assess the targets that were hit, and then to attack from a different angle so as not to hit those ships that were already sunk. There's always the danger that a ship commander can panic and empty a ship's entire missile magazines by firing them all off at once against a target. So fire control is essential. Here you can see a Soviet Cresta 1 ship. So this is from a text by Hughes, and he shows the different types of attacks. There's the massed attack from one location. There's the dispersed attack from different angles, which is very effective because it compels the enemy flotilla not to have their ships sequentially aimed at one direction of the compass, but having to disperse their defensive abilities in different directions. And they might even waste some of those ships defending against a direction from which an attack will not come. And then there's a sequential attack, whose advantages I indicated earlier. And you can see the consequences of the combat in terms of the advantages of a first strike in the chart on the top left. As with tank warfare, which we saw in a previous lecture, the benefits of a first strike in anti-ship warfare are significant. And so avoiding being surprised is a high priority for naval vessels. Here you can see in the photograph an Exocet missile having struck a British ship. So this is how a flotilla operates. This is a U.S. aircraft carrier, and you can recognize 2 of the aircraft. One is an F-14 fighter on combat air patrol. This is when you send an aircraft up and it simply flies slowly, waiting for an enemy target. And you can see the white aircraft, which is the E-2C with the radar, doing the detecting. The red aircraft is the Tupolev 26 backfire bomber that I indicated earlier, the Soviet aircraft during the Cold War that carried very long-range, very high-speed plunging cruise missiles. So the E-2C would detect this aircraft, and then the combat air patrol would intercept. And you can see the ranges in this case. The E-2C is 350 kilometers from the aircraft carrier, and you've got a missile defense zone, which some of the aircraft are operating in. You've got an inner zone where primarily the focus is on close-in weapon systems and stopping submarines that are very close. But this flotilla operates helicopters that are operating farther out, that are seeking submarines in the missile defense zone even. So in this case, the carrier battle group is using a layered air defense system. But there are also other layered systems to protect against submarines and protect against ships. Soviet surface ships also fire very long-range cruise missiles. So that's also a threat that needs to be considered. So here is a more detailed graphic. You've got the S-3 anti-submarine aircraft. You've got the helicopter chasing the submarine. You've got the E-2C early warning aircraft, as well as friendly submarines operating against enemy ships, enemy submarines, and enemy aircraft. and trying to avoid satellite surveillance by going underneath clouds. So with naval warfare, we're essentially looking at accelerated combat. You've got very high speed combat because of the nature of the technology and the absence of attenuating defense, although weather can have a significant role to play. Fleets are generally logistically self-contained. They don't have a rear like the Army units do, so attacking from the rear doesn't help, although fleets do have to replenish, and so they'll pull out of the line. And in the U.S. Navy, where they have significant logistical capacity, they'll pull back to an anchorage, typically in an atoll or an island or a bay along a coast, or even at sea if the sea is calm, resupply and resume combat with the in the naval campaign. Nevertheless, attacking an enemy fleet from many sides does have an advantage because it confuses the defender. So overall, naval tactics is actually very simple and has fewer elements than land warfare, but it's also far less forgiving. A surprise attack at sea is much more devastating than an attack on land. The Central Intelligence Agency in the U.S. was created in response to the devastating destruction that the Japanese were able to inflict at Pearl Harbor against the U.S. fleet on December 7, 1941. With nuclear weapons, surprise is even more devastating. If a nuclear arsenal is destroyed on the ground by an enemy nuclear arsenal, then there are huge strategic consequences, which is why the critical nuclear missiles of the U.S. are deployed on ballistic missile submarines deep in the oceans, rather than on land. This is the British ship HMS Coventry on fire. So this is from Kenneth Boulding, and he proposed a phenomenon called the loss of strength gradient, which is as you reach farther out from your fleet, you're going to have less power. Obviously, the aircraft that flies farther has to carry fuel tanks, and those fuel tanks displace ordnance, and so the aircraft has less weaponry as it's flying very far out. Also, the farther weapon systems are fired, as mentioned earlier, there are environmental causes and accidents and a higher likelihood that the enemy is going to be able to shoot down that missile because of the greater time offered for that in that missile's flight time to be observed. So on the top you can see red striking power, which is hypothetical, and you've got this gradually reducing gradient. And you can see the shaded area, which is the ability to reduce the effect of the ordnance at very long range. On the bottom graphic, you can see a different conception, and this is an abrupt drop-off in the firepower caused by a system not able to reach out. So it's possible that on the left of this graphic you have helicopters that can fly out, but they simply can't fly out beyond a certain distance. And then beyond that you have maritime aircraft, which are of much smaller number. So you can conceive of this as extending out from naval flotillas, and you can overlap these against each other to see what the optimal range is for one system to fight another system. Typically, U.S. aircraft carriers have aircraft that carry ordnance, and that ordnance is going to be deployed by the U.S. aircraft out of the lethal range of the enemy fleet's air defense system. Now that air defense system is going to vary for different ships and different flotillas in different countries, and so it's a complicated process to match the ordnance and the aircraft and the type of deployment and launch point when you're attacking an enemy fleet. Now, naval forces can engage in one of 5 missions. No particular ship type is associated with any mission. Most missions have some mix of different kind of ships. Balancing between these different missions is where the logic of the economy of force comes into play. However, at sea it is usually less useful than land warfare to have reserves for 2 reasons. One, it's easier to disengage in naval warfare than it is in land warfare. So ships can respond easily to new contingencies. They simply turn around and move away at flank speed, which is maximum speed. And second, The concentration of force is very important in naval warfare because having a large concentration of rockets coming in on a target causes the enemy to fire off all of their air defense systems to the point where they could be overwhelmed. And firing multiple torpedoes at a target can cause a flotilla to have to move in different directions and to compromise any one optimal path. Typically, when a torpedo is fired at a ship, it turns around and moves away at high speed. But as the torpedo becomes very, very close, the ship will then turn at a 90-degree angle, hoping that the torpedo will bypass the ship because the ship is moving across the front of the torpedo's sensors. But if you're firing torpedoes from multiple directions, that type of calculus becomes a problem because you can't really run away from the torpedo. Running away from one torpedo brings you closer to the other. And a 90-degree angle for one torpedo may not be a 90-degree angle for another torpedo. Here you can see a British landing craft that was used during the Falklands conflict. So the first mission is Naval Superiority. This includes the destruction of enemy surface, subsurface, and air forces, and ground bases such as ports and airfields in order to gain control of a sea area. Here you can see the British ship HMS Coventry, which was hit during the Falklands War. The second mission is commerce protection, to protect one's own merchant fleet. This can be done by destroying an enemy fleet, engaging in anti-piracy operations, minesweeping, which is to clear the sea lanes of anti-ship mines, and most commonly by escorting ships in convoys. Convoying of merchant ships consists of escorting large groups of ships by surface warships. It has a very long history. Convoying goes back to the classical times. The Romans had convoys. In modern times, the Dutch and the English would competitively convoy their ships in the Mediterranean and in Southeast Asia, in the Spice Islands of Indonesia. The Spanish would escort their convoys, typically of bullion, silver and gold, from the Caribbean to Spain, or from the Pacific coast of what is today Mexico to the Philippines and to China. There were controversies, however, because convoying was learned a little bit late during the conflict against Napoleon and very late in the First World War. In fact, it required civilian intervention by the British government to compel convoying. During the Second World War, there was much greater organization in terms of convoys. Basically, ships would be aggregated at ports like Halifax and then would be escorted across the Atlantic over the mid-Atlantic gap, which is a part of the mid-Atlantic where there was no aircraft coverage or no Allied aircraft escort for the convoy, and then on to England. Mathematically, there is a complex debate over why convoys work. Here you can see a torpedo in a torpedo room of a submarine. So more on the logic of convoying. So convoy tactics. The probability of detecting a convoy is the same as detecting a single ship. This is counterintuitive because we think of many ships as being a much bigger target. But comparing the size of a ship to the size of a convoy against the enormous vastness of the ocean, or even the vastness of a sea like the Mediterranean, makes the two almost equivalent. So concentrating ships into one convoy instead of a single dispersed ship spread out over the ocean actually decreases the average probability of getting detected, despite the danger that all the ships may be detected at once if that convoy is detected. If a submarine were to go out and patrol randomly, most of the time, the vast majority of the time, it would encounter nothing and that one convoy would slip through. So you need nets of submarines doing patrolling. One would detect the convoy and then the other submarines would converge on the target. Now, the second issue is that convoying also permits warships to act as escorts, which would be impossible if the merchant fleets were dispersed, because there are far more merchant vessels than there are military vessels. Number 3, escorts permit attrition on the attackers through retaliation, which could not occur if the merchants were dispersed. There are stories of famous theorists who are also practicing naval commanders, like Acoustics, who's a French admiral. And he noticed in his military service during the First World War, when he was a commander of a patrol vessel, that he patrolled for German submarines and never once encountered one. So the probability also of escorts finding submarines by patrolling is extremely improbable. There's a very interesting fictional movie based on a well-known book called Cruel Sea, which is a story, and then a black and white movie in the 1950s, of this British escort vessel. And at the end of the movie, the commander reflects of his Second World War service, which is a long 7-year service against the German Navy. And he counts, and I can't remember the number exactly, but in the entire 7 years, they sank 2, maybe 3 submarines and prosecuted about that many contacts. And believe it or not, that ratio of kills, 1 submarine every 2 years, is about the average for patrolling vessels. And his vessel was actually an escort. So patrolling is remarkably inefficient, and it's much more efficient to be with a convoy. And even if you are in a convoy, you still end up with the same statistics, which is the statistic in the movie Cruel Sea and the book. And that movie included the escort being sunk and the crew having to change to a new escort. So escorts moving with a convoy permit retaliation if a submarine shows up and attacks the convoy. Now, the equivalent prior to the First and Second World War you were primarily defending against fast-moving enemy frigates and cruisers. And in fact, during the First World War and the Second World War, you had ships like the Emden in the First World War, or in the Second World War, you had the Graf Spee and you had the Bismarck, which were German pocket battleships, high speed, that were intended not only to attack enemy warships, but also to attack surfaced convoys. And so you had dedicated surface ships chasing convoys also. And so the escorts had to be strong enough to deal with that as well. Now, you can also disperse the convoy, and this occurred in PQ-17, which was a infamous convoy that moved from England through the Arctic in winter to bring vital supplies to the Soviet Union during the Second World War, which was then defending against the Nazi onslaught. And this convoy carried aircraft, tanks, and other specialized ordnance. And the Germans used a combination of surface ships, the Gneisenau and the Scharnhorst. They used maritime patrol aircraft, the Condor, and they used submarines to attack the convoy. And most of the ships in the convoy were sunk, and then the convoy dispersed after it was detected. So individual ships then tried to make their own way either back to England to avoid the German attack or onto the Soviet Union. Now, the advantage of dispersing ships is that they're not slowed down to the speed of the slowest ship in the convoy. And whereas military vessels, like aircraft carriers, can go up to 30 nautical miles an hour, which is about 40 or 50 kilometers an hour, some merchant vessels only go at 10 nautical miles, which is 17 or 18 kilometers an hour. And so dispersing a convoy, particularly after it's been detected, allows evasion and decreases the time spent at sea, which decreases the likelihood of contact with an enemy submarine. The second benefit is that dispersal reduces the likelihood of a massacre if the anti-commerce threat of the enemy is concentrated against that convoy. So selection depends on the circumstances. The weaker naval power should typically use dispersed tactics, and the stronger naval power, which has the ships available to do the escorting, should use convoy tactics. The third mission is commerce destruction. This consists of the destruction of enemy merchant vessels, bringing maritime commerce to a halt. Tactics depend on the strength of the attacker. If you're a strong naval power, you simply impose a blockade using surface fleets, air-dropped or submarine-dropped mines, and aircraft. If you're a weak naval power, you will use mines dropped by aircraft and submarines, and individual raiding ships like the Graf Spee or the Bismarck. You can see in the picture on the bottom left a fleet oiler fueling the British ship Canberra, which is a cruise ship, but during the war was being used to carry soldiers that were going to land in the Falkland Islands. On the bottom right, you can see the Atlantic Conveyor, a ship which carried aircraft and helicopters and vital supplies to the British fleet. This ship was actually hit by an exocet from the Argentinian Air Force and was sunk with its valuable cargo, including Harrier aircraft and Chinook helicopters. The fourth naval mission is coastal defense. So it's the use of the sea and land-forced bases to keep an enemy away from operating near a friendly coast. And this can include minefields and coastal missiles. The People's Republic of China today uses the DF-21 missile guided by satellites to destroy U.S. aircraft carriers. The U.S. makes a bit of a public diplomacy deal about the power of their aircraft carriers against countries on a littoral, but it should be put in perspective. The U.S. almost never intended to use aircraft carriers against land-based aircraft bases because land-based aircraft are always stronger. Carriers have some prospect of survival if they're concentrated, but aircraft carriers are really only useful against weak countries or countries with weak coastal defenses, unless they're concentrated in large flotillas and the mission is vital. The main advantage of aircraft carriers is they're able to sweep a land-based power's fleet from the oceans, preparing it for a blockade. The picture here is of the British ship, the Sir Galahad logistical landing ship. The Argentinians fired an exocet from a land-based truck, which struck the vessel as it was waiting off a coast to be able to conduct a landing. It was in a bay. It had air cover, but there were insufficient smaller ships to land the Welsh battalion that was located on it, and the exocet killed 50 of those soldiers when it hit. The fifth mission is Amphibious Operations, or the use of naval forces to deploy land and air forces into an enemy territory. It is very dangerous. Land forces are much stronger on land because, of course, they can't be sunk and it's easier to hide. Where amphibious forces, whether they're landing by boat or helicopter, are very vulnerable. In this picture on the bottom left, you can see the Fearless in San Carlos Bay. And though while it's shielded from enemy Argentinian anti-ship missiles, it is exposed to the gravity bombs being dropped by Argentinian aircraft, piloted by very skillful and brave Air Force personnel. Also, when you're in a bay like this, the long-range air defense system doesn't operate because as soon as the Argentinian aircraft fly over the crest of the surrounding hills, that's when you first detect the aircraft. Although there were British aircraft operating at high altitude that could see the Argentinian aircraft from a distance. You can see a burning ship in San Carlos Bay in the bottom right. So this is a map of San Carlos Bay and where the landings were conducted by both ship and helicopter by the British Marines. And you can see the explosion of the gravity bombs as the Argentinian aircraft attacked the British fleet. And in the picture on the bottom right, you can see the Norland ferry and the Intrepid assault ship in San Carlos Bay. So this is a graphic representation of the U.S. Navy showing their force. The top line of ships are the aircraft carriers. Immediately below it are a class of Wasp, America, and Harper's Ferry. These ships are amphibious landing ships. So although the Wasp class and the America class look like aircraft carriers, and they carry aircraft, including the F-35 stealth aircraft and helicopters, their primary mission is to land a battalion of 1,000 U.S. Marines. The third line are the San Antonio amphibious transport decks and the Whidbey Island deck landing ships. Those ships carry the Marines, and they could carry about a division of Marines. That's about 15,000 soldiers onto a beach. Below them are the Ticonderoga class. These are cruisers with very powerful phased array radars that reach out hundreds of nautical miles, and they can coordinate through a computer system all the radars and missiles, air defense missiles, of all the other ships in the flotilla. So it's basically a giant floating computer attached to a radar that coordinates other ships. Beneath that are the Arleigh Burke class guided missile destroyers. These are very powerful U.S. ships that are multi-role. They can fight aircraft, ships, and submarines. And then beneath that, you've got your frigates and smaller utility vessels and a number of submarines. So you see the U.S. Navy is not very powerful in terms of the number of ships. It's powerful in terms of its aircraft carriers, and all the other ships are intended on providing escorts to protect that aircraft carrier. The firepower of an aircraft carrier is significant because aircraft can fly again and again and again, whereas missiles launched by ships can only be fired once, tend to be less efficient than an aircraft carrying ordnance, and are basically much less cost effective. But operating an aircraft carrier is a very complex activity, requiring a high level of training and a high level of technical competence, which most countries have not yet mastered. The U.S. currently has more aircraft carriers than the rest of the world combined, both friendly and enemy. These are the fleets, or rather the ships, in the fleet of the People's Liberation Army Navy, of the People's Republic of China. Currently, China's got 3 aircraft carriers, not 1, and 2 amphibious ships, which is the ship you see, the very large silhouette, which you see at the bottom left. And the Chinese fleet has more surface vessels than the U.S. Navy, but they have less vertical launch systems on all of those ships added up together. And the aircraft carrier has various issues, including an aircraft that can't carry a lot of ordnance. It doesn't carry a lot of aircraft. And the Chinese have less experience operating flotillas around their aircraft carriers. Also, the Chinese are generally weaker in anti-submarine warfare. So although China and the U.S. have the same number of submarines, and some of the submarines that the Chinese have are quite quiet, the U.S. would be able to, with current technology and capabilities, overwhelm a Chinese aircraft carrier with submarine attacks. In air attacks, the situation is as imbalanced, except the Chinese aircraft carriers are very likely to operate very close to the Chinese coast, and so they would benefit from coastal air defense. A Chinese aircraft carrier operating far out to sea would be extremely vulnerable to long-range U.S. Anti-naval aviation. This is the British fleet, which used to be quite large but has shrunk significantly. It would be accurate to describe the British fleet as very local. Now, the fact that the British have 2 aircraft carriers means they're moving their strategy in the direction of close association with the U.S. from a strategic point of view. In other words, the British don't really have an autonomous defense policy. They've tied their defense policy in very closely to the U.S. because the British have a lot of long-range interests, like islands in the Pacific, the Falkland Islands. They have sovereign territory on Cyprus. They have islands in the Central Indian Ocean. They have Gibraltar. So these territories are difficult to defend for such a small British fleet. So by associating their fleet with the U.S., they basically diplomatically benefit from U.S. security. So the British have committed their aircraft carriers to operate in the Pacific region, where they have very few actual territorial interests, but it gives them a global diplomatic role. This is the French fleet. The French fleet has an aircraft carrier, and they focus mostly on operating within the Mediterranean and the Atlantic coast. So the French have a focus that is very European, and most of their interests are in Africa, and they have a territorial interest in South America, in French Guiana. And there are French islands in the Indian Ocean and Pacific, but they're, again, associated with a local French flotilla. This is the Italian Navy, which is actually substantial. The Italian Navy is designed to operate in the closed waters of the Mediterranean and, if required, to provide escorts to the Persian Gulf and the Indian Ocean and the Red Sea to escort the supply of fuel that comes from there. The Italian fleet is actually quite powerful, and it actually has a strong tradition, both in the Second World War, where the Italian Navy essentially modeled itself on the British Navy. And although they didn't perform very well, it was partially associated with the fact that the Italian Navy was always Anglophile and didn't really want to fight the British Navy. And they had a very strong performance in the First World War, where they defeated and isolated the fleet of the Austro-Hungarians. The Italian aircraft carriers and their escort ships are particularly powerful in the closed-in water. So they've got good air defense and good anti-ship systems, because the Mediterranean, while it's quite large, is in fact much smaller than the Atlantic. And so for the purposes of fighting enemy aircraft, and there are potentially hostile aircraft in many of the countries on the Mediterranean littoral, like Libya, for example, the amount of time it takes for an aircraft to go from a coastal base to the center of the Mediterranean is quite short. Here you can see a representation of the size of different submarines and aircraft carriers. You can see the preponderance of U.S. power. China should in fact have 3 aircraft carriers listed here. So this gives you a sense of the size of modern submarines on the right compared to the largest Japanese submarines and the largest German submarines during the Second World War, which were significantly smaller. Now, what remains for this lecture is the student has to go watch the Poly 318 Harpoon tutorial, which is also posted on UJA. This will guide you in how to play and set up Harpoon for your Harpoon naval assignment. Now, the particular video I'm going to show you is from a different class, which focuses on nuclear strategy and naval strategy. So what we're doing in this class is purely conventional. So listen to the tutorial for Harpoon, but disregard all of those lessons and instructions and actions involving nuclear weapons. Now, there's 2 reasons why you're prohibited from using nuclear weapons. So do not press Alt F3. The first is I'm going to find out. The second is nuclear weapons can be very powerful. However, the Soviet fleet, which is in the Arabian Sea, has significant nuclear capabilities also. And if you enable nuclear weapons use, the Soviets are going to use nuclear weapons against your fleet and likely destroy it. So for your assignment, do not hit Alt F3. Just fight as best as you can with the forces that you have available.